Hello, everyone, and welcome to Tech SEO Mini Boost. We are just so excited to be gathering today to discuss, explore, and geek out on some technical SEO. My name is Megan Lavin. I'm the Director of Marketing at Catalyst, and I have the great pleasure of being one of your MCs today alongside the amazing Paul Shapiro and the fabulous Aleda Solis. Paul and Aleda, do you guys want to introduce yourselves and say a few words to the audience?
Hi, audience. I'm Paul Shapiro. I'm the Global Director of Technical SEO for Condé Nast and their publications. You may know me from past Tech SEO events. I sort of started Tech SEO alongside Catalyst, and I'm happy in the wake of this pandemic that we're able to still get together and chat some technical SEO.
Yes, thank you for the opportunity to be here today. My name is Aleda Solis. I am an international SEO consultant and founder of Oranti, my own boutique SEO consultancy. I am delighted to be able to share with you today. I've had the opportunity in the past to be one of the judges of many activities that are connected with the conference. So today, to be able to be here co-presenting it is amazing. It's a wonderful opportunity also to be able to see so many great presentations and topics. It's so very exciting and very happy to be able to comment on a few of them too. So thank you for having me.
Thank you, guys. I'm super excited to be partnering with you on our MC duties today. And I just want to call out that everyone probably heard me say, welcome to Tech SEO Mini Boost, right? And that's because the goal of today's virtual and streamlined experience is really to sort of hold us over until we can all get together in Boston and again for the physical event. I think, we just miss the Tech SEO Boost community so much. And once it's safe to do so, we certainly plan to resume the physical event. But until then, we hope you enjoy Mini Boost because we have a lot of good content on deck today. And with that, Paul, do you sort of want to walk the audience through the agenda at a really high level and call out some of the major themes and takeaways for today?
I would be delighted. So kicking off in the morning, Simo Ahava is our welcoming keynote, and he's going to be talking about server-side Google Analytics implementation. I am so thrilled that Simo was able to join us and chat about this amazing topic. Right after that, we're going to kick off with our Python panel dedicated to the late, great Hamlet Batista. I'll be your moderator for that. And we have an incredible panel of guests to chat about Python in the world of SEO. Following after, we have a short break, followed by Jamie, the return of Jamie, who's going to be chatting a little bit about core web vitals and how to improve them. And then we have another returnee after that, Brian Ta, who's going to chat about SEO experimentation and A/B testing. Brian's with Coinbase, and he's been with a million startups at this point. He started when he last spoke. He was with Airbnb, and did tons of testing at Airbnb, and then AngieList, and so on and so forth. So he's a great person to be talking about that. We have another break at 11:35 a.m. Then we're followed by another panel talking about evangelizing technical SEO for greater understanding, adoption, and impact. And around 12:30, we have Upasna from CNN giving a presentation on cultivating a product mindset for SEO success, something that I'm incredibly interested in and I think is the future for all SEO teams. So I'm incredibly excited for that one as well. And then we'll close it off with final remarks and an encore presentation from Simo.
Awesome. Thank you, Paul. And Aleda, you mentioned, you've been involved in the event in the past. You've been a research judge. You've seen some of our past content. But what are you most excited about for today's event? What are you most looking forward to?
So I am very looking forward the presentation from Jamie, because she's going to talk about core web vitals, but in a completely different way, I believe, from the many resources that have been published until today. It's about how the way that we render our websites actually end up negatively affecting, unfortunately, in most scenarios, the core web vitals, the metrics that are taken into consideration. And then she goes through the different pros and cons of the many different approaches that we can take for our website rendering. So I don't think that I have read anything like this or seen anybody like take this very detailed analysis and process to go through all of the different approaches to render our content using JavaScript client side, server side, hydration, like I'm telling you, this is fantastic. You cannot miss this presentation. So I'm very, very excited about that one. I am also so very excited about the panel going through Python and SEO, because it's true that there has been a lot of resources, a lot of scripts that have been shared lately. But I love this panel because literally it goes through the different type of scenarios and areas and consideration to take in our day-to-day to make sense of how we can leverage Python in a way that is cost effective, that makes sense, that correctly blends in our SEO day-to-day. So I will also highly recommend you to not lose any of this too, and also any of the others, because literally I could go on and on and on. Don't make me tell like which is my favorite. I love them all. You will see is an amazing blend of all of these areas that have been very hot topics lately, and with a unique approach every single time.
Awesome. Thank you. Yeah, I definitely won't make you pick a favorite, and we'll have time to talk about each and every one of them. So awesome stuff. And I think it's clear that there's a lot of really amazing content on the horizon today. But before we get to that amazing content, I do have some obligatory housekeeping remarks just to make sure everyone gets the most out of their experience today. So first, for anyone new to Tech SEO Boost, the event is hosted by us at Catalyst. Catalyst is a performance marketing agency that specializes in, of course, SEO, but also paid search, social, programmatic, e-commerce, retail media, and loads more. And you can learn more about us at catalystdigital.com. And in terms of our platform today, so we're going to be using the Visibo event platform for the conference today. And the agenda tab on our event site is really going to be your gateway to all of the day's presentations and in panels. You'll be able to click into the agenda tab, see what session is live, and then click into that session to join in real time. And now the Visibo platform is pretty straightforward, pretty easy to use. But if you do have any questions about the platform, if you encounter any issues as you're viewing content, we do have a team from Visibo on standby, ready to jump in and help you troubleshoot and problem solve any issues in real time. You can reach out to the Visibo folks by using the chat feature that's at the bottom of the agenda page on our site. You can also find it on the homepage, so please feel free to contact them if you run into any issues whatsoever. And then in terms of questions, so you can submit questions for our speakers using the Q&A icon on your screen, and you can submit your questions anonymously, or you can include your name. And just know that how we're going to handle questions will vary session by session. So in some cases, we'll have speakers live in backstage with us, sort of manning the Q&A and responding to your questions in real time during their sessions. In some cases, we've also pre-sourced questions in which the speakers will address those during their presentations. But regardless, we'll be collecting all of your questions at the end of the event and doing some follow-up to make sure you guys get answers. Now next, just a huge thank you to our partners. Over the years, we've been fortunate enough to have some truly out of this world event partners and supporters. And so we're bringing them along for our virtual experience today. So throughout the day, what we're going to be doing is starting each session by checking in with one of our partners. We're going to get a quick hello from their team. We'll hear, what they've been up to since we last saw them in Boston. They'll share the latest and greatest at their companies, and they'll walk us through some of their offerings, capabilities, and tools. Some of them will also be sharing promos, free trials, and loads of other goodies. So we're super excited to have them all involved. And we're actually going to start with OnCrawl today. So before we get into the Simo's keynote, we're going to check in with the amazing team at OnCrawl, hear what's new and hear what they've been up to. So let's get a quick hello from the OnCrawl team.
Hey, welcome. It's great to see you here at the TechSEO Mini Boost. If we haven't talked before, I'm Rebecca from OnCrawl. You might remember OnCrawl from 2019 when our product director Vincent Terraziz worked with GPT-2 for SEO in any language, won third place at TechSEO Boost Boston. Since then, we've released OnCrawl Labs with pre-coded machine learning and data science projects that build on the data in the OnCrawl platform from our SEO crawler, log analysis, and diverse connectors. If you were particularly interested in Vincent's work with text generation, keep an eye on what's coming soon from OnCrawl. Not only do we have some new features in the works, but we've also been playing around with GPT-3 and working on making sure that your SEO data, no matter how much of it there is perfectly compatible with however you do your analysis and whatever platform you use for reports, dashboards, and visualizations. I speak for the whole OnCrawl team when I say that we'd love to share our enthusiasm. So if you want a free 1-month full-featured trial, reach out at oncrawl.com/TechSEO Mini Boost. It's on the screen. We know you're here for the amazing talk coming up right now, so enjoy your conference.
Thank you, OnCrawl. Great to hear from you guys, and just so excited to have you involved in the event again. And with that, we're going to transition into our keynote. So our keynote today is from Simo Ahava. He'll be presenting "The Future is the Past, Tagging and Tracking Through the Server." And here's a little Tech SEO Boost history lesson for you. I think we've tried to get Simo on our speaker lineup for maybe like 2 or 3 years now. It's just never worked out because of logistics, scheduling, travel, and whatnot. But it has finally worked out this year. I know I'm excited to have Simo on the agenda. Paul and Aleda, I know you guys are super pumped for this one. Before we kick things over to Simo, do you sort of want to weigh in on why Simo's topic is so important and why he's always been at the top of our speaker wish list?
Yeah, I mean, Simo is incredible. I think no one knows GCP as well as Simo. If you've ever read his blog, you know that he's the go-to guy for anything Google Tag Manager, GCP, and he's just always putting out incredible work for everyone. And this is an amazing topic. The ability to do Google Analytics tracking through the server. I couldn't be more excited to have him.
Yes, indeed. I actually like the way he tackles this topic because indeed, like he always tries to not only give like the tactical step by step to do some things that are quite highly technical but very, very creative at the same time, but also I love how the way he approaches these topics, like for example the implications on data governance and what is reasonable to do and best practices, because it's not about just implementing whatever new technology comes in place in order to do something that, well, there might be additional implications to take into consideration from an organizational standpoint, right? So I love how he blends these topics and he approaches this from, let's say, a very mature way from an organizational standpoint. So I do believe that even if you have been reading a lot of his articles that he had been publishing about this particular topic, the new insights that you will be able to learn with Simo today. So I'm so very excited for this presentation in particular.
Wonderful. So without any further ado, let's welcome Simo Ahava.
Hey everyone, thank you so much for the kind introductions. I'm finally able to join this wonderful event after years of bouncing ideas around with the organizers and coming virtually to your homes this time. I'm so excited to talk about server-side tagging. I think it makes for a wonderful generic conference presentation because it's so all-encompassing. Everything can be covered by the magic of server-side. And in a very real way, we are going full circle back to the roots of digital marketing, digital analytics. For many of us who've been in the game for a while, we've started with server-side parsing, with server log parsing, with server-side mechanisms, collecting information between servers, and the client has only been an inconvenience in a way. After the introduction of JavaScript and client-side technologies, obviously the client-side tracking and the client-side tagging formats have become the norm. But it's kind of funny to see how we're going back full circle to our roots. And maybe we can uncover something completely new with the full scale of the cloud tech helping us along the way. In this presentation, I want to talk about server-side tagging in general, what kind of problems it addresses, what we can expect from it in the years to come, and why I think it's a full-blown paradigm shift in how we do analytics work. A quick few words about myself. I'm the co-founder of two companies. One is called AP Cheap, which is a digital services boutique consultation agency based in Finland. We offer data services to clients and customers alike. And the other is Simmer, which I founded with my wife last December, mid-COVID. And it's an online course platform. And I'm going to be mentioning one of our courses later in this presentation. I'm also a Google developer expert for Google Analytics and Google Tag Manager. I'm not employed by Google, but I am a community specialist helping them share the love of developers and the love of analytics development work. I have a blog at simoahava.com, which is, if any of this tickles your fancy, then you'll find a lot more content about server-side tagging and analytics development work in general. I'm a fairly active Twitter user with my name as my handle, and I'm also the curator at cookiestatus.com, which is an online resource about browser tracking protections, which are also quite relevant when it comes to server-side tagging, as you'll hopefully notice soon. Before we step into server-side tagging and the kind of problems it addresses and the promises it makes, I think we need to establish what tagging in general means and what the current paradigm of client-side tagging actually is. With tagging, we start typically with a website. Obviously, there are mobile and app-specific tagging systems out there as well, but we typically start with a website. And on that website, we run a tag management solution. Google Tag Manager is one of the most popular ones, but there are others out there such as Adobe Launch, Telium, and Citon, and so on. But the basic logic is always the same. Tag Manager is designed to collect and collate and curate all those calls that you want to dispatch to vendors like Facebook, Google Analytics, Google Ads, Hotjar. It makes it easier to deploy those marketing and analytics pixels on the website. But what ends up happening is that the browser makes direct HTTP requests to these vendors. So when the tag manager needs to send something to Facebook, it needs to actually communicate with Facebook's endpoint. And this starts with a CDN call. So the Facebook library or the Google Analytics library or the Google Ads library, they're all downloaded from a third-party content distribution network. And when you do this download, you're subservient to whatever ails this third-party source. For example, if the domain is down, if there's an attack going on the Google servers or Facebook servers, that CDN might become unresponsive. So you're always kind of have to hope and pray that nothing's wrong with the library download itself, because if the library doesn't download, then nothing will be able to get done on the website itself. Another kind of offshoot of using these HTTP requests is that these vendors can essentially use your browser as a cookie store. So they can drop both first-party cookies by just running some JavaScript in the browser, and they can set third-party cookies in the HTTP responses themselves. So when the browser communicates with these vendors, the browser kind of voluntarily becomes a guinea pig for storing cookies and other persistent data on the user's browser. And this is problematic, especially, well, for many reasons, but especially in the European Union, where the e-privacy directive is very strict on what type of information can actually be stored in the terminal device, such as the browser or the mobile app, without consent. Another thing that cookies enable, and a very concrete thing that cookies enable, is cross-site tracking. So this is how Facebook and DoubleClick and all these other services can build these large programmatic audiences out of your website behavior, what you do on different sites. And it's not just what you do on the site running GTM, it's what you do on almost any site in the web that runs a Facebook pixel or that runs a DoubleClick request. And these cross-site tracking audiences are how you can get targeted by more specific ads, which might be a good thing for some, but it's also a way to enforce those political bubbles and to make sure that your news feeds are full of information that you subscribe to, and that don't kind of break that bubble for you. There's a lot of research on the dangers of cross-site tracking, and I'm not going to go too deep into that here. But for cross-site tracking to work, one of the prerequisites in many cases is that the browser communicate directly with the vendor endpoints. After the libraries have been downloaded, obviously, then there's the tracker pings themselves. So when a conversion happens, or when a page is viewed, or when an add to cart event happens, the browser communicates with these endpoints and tells them that something happened. And every single one of these tracker pings is also an HTTP request carrying all the aforementioned baggage, such as cookies and potential for cross-site tracking as well. And there's also no validation mechanism in between the browser and the vendor. So if you're collecting invalid data, if you're missing certain attributes or missing certain metadata, there's really not much you can do in the client because the vendor just collects the data as is. Sometimes these CDNs and the communication with a third party can lead to cross-site scripting attacks or man-in-the-middle attacks, not necessarily with large profile domains such as Facebook and Google Analytics, but especially with smaller vendors that can get hijacked or that can get manipulated into turning their subdomains into attack vectors. And this is becoming more and more common with so-called CNAME cloaking, which is one of the reasons why browsers are actively working against this kind of mechanism. So cross-site scripting attacks also require that the browser communicate directly with these tainted endpoints. And it's, again, an offshoot of using this type of a direct request mechanism between the browser and the vendor. And then finally, in this list, one of the more prominent problems are personally identifiable information leaks from the browser to the vendors. So anybody who's worked in Google Analytics knows that PII data is so easy to flow into Google Analytics simply because it might be in the URL, an email address might be in the URL, or maybe the site visitor types some personal data into a site search bar, for example, because they thought it was a customer support request form or something. I've seen that happen, actually. So PII can leak into these vendor databases, and that's a huge problem. That's a problem from a legal perspective. That's a problem from the terms of service perspective of these vendors, and that's also a problem for your brand if it kind of comes to light that you've been collecting this kind of data breach data, such as PII. It's possible that the brand windfall and the kind of attack, public action against you will be insurmountable, and you'll find yourself in a lot of problems when having to explain to your customers why their data has been leaked to these vendors. So these are all kind of negative things that come with regular client-side tagging. This presentation is not an attack on regular tagging. That's still 99% of what I do for a living. But we do have to recognize that when communicating with vendors directly from the browser, these types of problems emerge, and they emerge more and more each day and month that passes when the attackers get more sophisticated tools to do this. So when we then move to server-side tagging, let's see how all of these points are addressed in a kind of a new way. With server-side tagging, you still have the source of the data, such as the website or the app, and you still have the vendors that need the data, such as Facebook, Google Analytics, and Google Ads. But with server-side tagging, instead of the browser communicating directly with the vendors, something is inserted in between. And this thing that is inserted in between is a server container or the server-side tagging endpoint. So it becomes a buffer between the data source and the target of the data. And the key thing is that your organization owns this buffer. So it's essentially a server-side proxy. It proxies the requests from the browser so that instead of them being sent directly to the vendors, they are shipped through the container first. And let's see what this actually enables. First thing that it does is hit validation. I mentioned the problem of sending invalid data to these vendors. So with a server container, you can actually build rules that look at the incoming data, look for potential data quality issues, and then fix them in real time before sending the fixed payload to the vendors. A prime example is Google Analytics, where if you try to send an event hit that has the event value parameter set to anything other than a number, such as a string or a Boolean, that hit will be sent to Google Analytics, but Google Analytics will not process that hit. It's discarded as invalid. So in the server container, all you have to do is do a simple regular expression check against all the incoming event values. And if any of them is not a number, then convert them or cast them to a number format so that the hit is sent successfully to GA. The other thing that it enables is stream consolidation. For example, in this image, on a very abstract level, you can see that there's only one request departing the browser, but there's 3 requests departing the server container. The point behind stream consolidation is that when a conversion happens, for example, it's always almost the exact same information dispatched to each of the vendors, just with a slightly different semantic output. So for example, a purchase would be sent as a purchase event to GA, or a transaction event to GA, a purchase event to Facebook, and the conversion event to Google Ads. But things you always have in those are the transaction value, order ID, maybe some item level data. So it's the same information just packaged in different ways. So when the same information is sent 3 times from the browser, once to each of the vendors, it's quite redundant. And it's a lot of overhead for a simple conversion stream. Whereas with a server container, you only have to send a single conversion event to the server container, where it's then parsed and distributed and multiplied and duplicated to all these different vendors. So you're reducing the outgoing bandwidth from the client. You're reducing the amount of information the client has to distribute from the browser. Then we have the concept of anonymization. One of the offshoots of using HTTP requests to send information directly to vendors is that the vendors will see in their server logs the incoming requests, their IP addresses, the user agent strings, and so on. So they can use this to build and to enhance their fingerprints of the browser. But with the server container, what you can do is hide the origin IP address and the origin user agent and any other information of the origin, so that the vendors only see the IP address of the server container itself and the user agent, whatever you choose to update the request with. So you're building a complete obfuscation system where the information is completely anonymized. Google Analytics anonymization feature, for example, anonymizes the last octet of the IP address, leaving still 3 octets worth of information. It's not enough to identify an individual machine, but it might be enough to identify the company or the organization sending the data. But the GA would still receive the full IP address in the HTTP request logs. But when moving to a server container, Google Analytics would only see the IP address of the server container. And you can choose whether to use the provided parameters to send the origin IP address as well. But you can also choose not to send it, in which case the request is completely anonymized. Consent management is typically a very difficult thing to get working in client side due to things like race conditions and just having a complicated consent mechanism running in the client, where you can move that logic to the server as well. So send all the requests from the browser as they would be sent, and then in the server, evaluate and validate consent based on cookie values, for example. So move that heavy lifting away from the client to the server. And all of these things, such as stream consolidation, consent management, and using a proxy in the first place, lead to improved client-side performance. You don't have to load a bunch of JavaScript libraries in the browser anymore, because all you need to do is send that single request that might represent 5 or 6 different JavaScript libraries worth of downloads. So you're doing a lot of work to reduce that annoying client-side load from the browser. And we all know how important it is to reduce the time to load. And then there's this idea of tracking protection. It's not a typo, where the server container can be used to alleviate some of the effects that WebKit's or Apple's intelligent tracking prevention has on your data, for example. So ITP truncates the lifetime of client-side cookies to 7 days or even just 24 hours, whereas with a server container, you can recycle those cookies and have them reach their typical untruncated expiration. So these are all the kind of high-level benefits of a server container. Let's dig a little deeper into these before going to an example of what can concretely be done with the server container. One of the things that a server container, or one of the USPs of a server container, is that you own the server environment. This is super, super important. You own that server container. It's not running, it doesn't communicate with Google, it doesn't communicate with Amazon. It's running in your own set of virtual machines. By default, it's running on the Google Cloud Platform, so it uses App Engine as the default setup. And so now obviously concept of ownership is bound to how much you trust Google when they say that you own those endpoints. But this is a question of infrastructure as a service, and it would be odd if Google ever kind of walked back on this promise of ownership. But even if you don't trust Google on this, server-side tagging is completely portable. It's running on a Docker container, and you can basically set it up on Amazon, on Azure. You can set it up on-premise, running in a server farm in your closet if that's your thing. But the key thing is that it's completely portable, and you can choose the exact environment where it runs. It will occasionally communicate with Google servers when communicating with the GTM user interface or when fetching updates. But it's not like the Google Tag Manager library. It's not running constantly in the Google Tag Manager servers. The reduced client load is pretty impressive, considering that you can get rid of all those third-party JavaScript libraries that end up doing the exact same thing as the next one. So instead of loading Facebook, Google Ads, and Google Analytics, you might actually get by with just the Google Analytics library, and then in the server container, dispatch the hit to Facebook as well and to Google Ads. So that's one of the big promises. This is idea of reduced client load and the reduced number of third-party endpoints the browser needs to communicate with. And this last point, the reduced number of third-party endpoints, is key to content security policies. Content security policies are a way for a website to delimit the number of connections that a browser can make. So if the site has a content security policy or CSP, all the third-party domains from which scripts can be downloaded or to where image requests can be sent need to be enumerated in the CSP. So you need the googletagmanager.com there if you want to download the GTM library from Google servers. Every single domain added to the CSP makes the CSP weaker. The CSP is stronger the fewer domains are listed, because each one of those is basically a backdoor to the website. So when you're moving to server-side tagging and you're reducing the amount of those third-party JavaScript libraries that need to be downloaded, or reducing the amount of tracker pings and domain endpoints that need to be communicated with, you can also reduce the size of the CSP. You can get rid of the Facebook endpoint. You can get rid of the Google Ads endpoint. All you need is the Google Analytics endpoint so that you can download the Google Analytics library. And I'm also I'm seeing a future where instead of using these large third-party libraries in the first place, super small, efficient, vendor-agnostic JavaScript libraries emerge purely for sending that JSON stream to the server, where the server can then dispatch it to GA and to Facebook and so on. So you might even get by without having to download any third-party marketing libraries or advertising libraries, assuming that these vendors provide the endpoints that are necessary to communicate with them. Because we're working in the server, we can expose information there that will never be revealed in the client or in the browser. So we can add secret keys to our requests to reduce spam. We can communicate with third-party APIs and have the API keys wide open in the server container, because none of that information will leak into the browser. From the browser, it's typically really awkward to communicate with third-party APIs because the API key is usually sent in plain text or processed in plain text in the browser, which means that it could be stolen and misused. But in the server, you can run all these enrichments if you like. And this idea of communicating with APIs in the server container can lead to, again, reduced client-side load. When, for example, for transactions, instead of sending the full transaction payload in the request, all you do is send the transaction ID to the server and then use a custom API to pull in the rest of the transaction using that transaction ID purely in the server-side endpoint. HTTP responses can be utilized, so you can proxy and cache sub-resource requests. So instead of downloading the analytics.js library each time from Google Analytics servers, you can actually store it in temporary storage in the server containers. So for 24 hours, for example, no additional requests to Google servers are made, but the library is always loaded from your server-side cache. You can also just simply recycle those libraries. So instead of having to load the library from googleanalytics.com, it will be loaded from your server-side endpoint. So it's a very typical reverse proxy kind of thing where you are providing a new domain to load familiar libraries from. You can also use the set cookie headers. So this is what you would use if you wanted to deal with Safari's or Apple's 7-day expiration of JavaScript cookies. You would rewrite those cookies in those set cookie responses, and that will give them their expiration back. So this has all been a lot of just pros and positive things and gushing over server-side tagging, but I don't want to finish this presentation without discussing the cons as well, and there are a few. The first one is that obviously when you're starting to proxy the requests for the analytics library from your endpoint and when you're sending those pings first to the server container, one of the quote unquote benefits is that you'll be able to circumvent ad and content blockers because they have heuristics looking for the domain names typically, sometimes for the path component as well, but most typically just for the domain names, meaning that as soon as you load the data from your own domain, you'll be able to circumvent these. I think this is a con. I think this is not a good reason to use server-side tagging. For one, when a user uses an ad blocker, they have the expectation that they are able to block those ads, and they don't need to give you a reason why they're doing so. So when you're using server-side tagging, you might inadvertently or completely intentionally kind of refuse to comply with the user's wishes to block this information. So there's no mechanism to prevent this. It's just a natural way of how server-side tagging works. But I do imagine that at some point it can be a good thing for your brand to consider being more open about the server-side tagging setup and giving the users a way to opt out, maybe checking if they have an ad blocker, and if they do, then prevent those hits from departing the server. A very similar concern is just the general opaqueness of data collection. When you send, for example, a consolidated data stream, so only a single request to the server container, where it's then split into Facebook, Google Analytics, Google Ads, and so on, you're increasing the opaqueness of data collection. You're hiding from the browser what actually is done with the data. And this can be very concerning from a consent perspective, for example, because the user has no way of verifying that their consent is being respected. With regular tagging, all the user has to do is check if Facebook is being communicated with from the browser. But now that the actual request is departing from the server, there's no way to verify this. So again, this is something that you need to take into account if you want to be more transparent about your tracking practices. Maybe add a few lines to your privacy policy, maybe improve your consent management system to also report back to the browser what is being done in the server environment. The server container uses a restricted sandbox of JavaScript. So any kind of templates, any code that needs to be run needs to obey the sandbox rules. And the sandbox is fairly restrictive. Google is adding more and more APIs to the sandbox all the time, but there are still many things missing that we might consider important before we can jump to it. For example, there's no consent management mechanism in server-side tagging yet. You just need to manually parse every single cookie and looking for those values that way. Cost is a thing. Server-side tagging running in a production environment. The recommended setup is 3 App Engine flexible instances, which are able to shoulder some dozens of millions of requests per month. And the cost for that kind of a setup is around 110, 120 euros. So that's $130, $140 USD per month. That's the price you pay for server-side tagging. Obviously, if you collect a lot more data and if you have more complicated computation tasks, that cost will increase. And in converse, if you have far fewer requests per month, you can maybe scale down to just 2 instances. But it's an auto-scaling setup, so App Engine will handle for you whenever more instances need to be scaled up to. I've run server-side tagging successfully on a site that collects almost 200 million requests per month, and we've managed pretty fine with 3 to 4 baseline instances. So the cost is typically around 100 to 150 euros. It might balloon up to 200, 250 if you need the full spread of 6, maybe 7 or even 8 instances with traffic spikes. Whether or not that's a lot of money is obviously up to your organization's budgets, but from a gut feeling perspective, it does sound like a fairly reasonable price to pay for the improvement to data quality that you receive in return. The one big problem is the poor availability of vendor endpoints. So no matter how much you want to move stuff to the server, it just might not be possible yet. And this is obvious for companies that require third-party cookies, because third-party cookies would not work on a server-side setup because it's running in your first-party namespace. So brands like Facebook and Google that require or rely on third-party cookies have been rushing to move to first-party over the last years. And Facebook, for example, now suggests that you send the first-party cookie values for the Facebook Click ID as well as a hashed email address or other hashed personal data. So for vendors to be able to add those endpoints, they'll need to, first of all, document how to communicate with their services with a server-to-server call, and also how to solve the problem of identity if they require some other identity than a first-party identifier. I also want to just walk through an example of how this idea of reducing client-side bloat can translate in a real world scenario. Obviously, this is still a fairly abstract. I don't have live coding for you, but this is an example of the thought process that happens when you move to server-side tagging. The starting point is a web browser that needs to send information to Facebook. To send this information to Facebook, first thing that needs to be done is add the Facebook domain and origins to the content security policy. Once they're added to the CSP, only then can the browser actually send HTTP requests to Facebook. Then the browser needs to wait for the CDN to respond whenever a page is loaded. Facebook is obviously pretty fast. They have an impressive infrastructure, but you could have a firewall in between. You could be using a VPN. You always need to wait for that CDN to fire off a response. And it's obviously entirely possible for Facebook to lag every now and then for a number of different reasons. When the request is sent, it's also logged to Facebook servers. So no matter how much you try to prevent your personally identifiable information from departing the browser, the IP address, which is deemed PII, at least in some European regions, is logged into Facebook logs and will remain there until Facebook decides to delete them with no notice to the user, of course. By communicating with the endpoint, you increase the risk of cross-site scripting attacks and man-in-the-middle attacks. Obviously, it requires that either the Facebook endpoint is taken over, or an endpoint that looks suspiciously like Facebook's endpoint is taken over and then kind of socially engineered so that your site will send requests to that instead. And this happens fairly often. And it's the basis of how things like MageCard attacks work. But the point is that when you send those requests directly to Facebook, the risk is very strong. It's there. It's very difficult to mitigate that when the browser is directly communicating with Facebook. You're also going to have to rely on third-party JavaScript. You're going to have to hope that the Facebook JavaScript doesn't mess up your site, which has happened, especially with their history tracking and the way that they collect conversion pings using a form element rather than an XML HTTP request, for example. But again, the key thing is that you're downloading JavaScript from a third-party vendor, and there's no way to validate or vet it for what it does. You just have to trust and rely that Facebook doesn't do anything nasty with the JavaScript library. And then the general spread of identifiers and cookies used for cross-site tracking that are being shipped with these requests. So this is the kind of repeating, going full circle back to the beginning of the presentation. This is the baggage you have when communicating directly with Facebook. So when moving to server-side tagging, let's look at how we address each one of these. First of all, you won't have to add the Facebook origin to the CSP anymore because you're communicating with the server-side tagging endpoint, which is most likely running in your own domain. So you'll be able to potentially get by with no CSP updates. You also won't have to wait for the Facebook CDN to respond anymore because the browser is no longer communicating with the Facebook CDN. Instead, you need to wait for the server-side endpoint to respond. But the cool thing is that you have full control over caching, and you can do extended caches, for example, for days on end, if you're sure that the third-party vendor's library is unlikely to change at that time. The request itself will no longer be logged into Facebook servers because you're no longer communicating with Facebook servers. It will be logged into your logs running in the server environment. But again, this is owned and controlled by your organization. So all data processing and data controlling setups that apply here would apply to your server-side endpoint as well. So it's between you and your customers for how that data is being processed. But it's not a third-party vendor with whom those requests are shared. You won't be able to get rid of cross-site scripting risks and man-in-the-middle risks altogether, because you might still be downloading those malicious or harmful libraries in your server container. But you will be able to prevent the browser from downloading them directly from the vendors, which means that in the server container, you can run simple integrity checks, for example, against those libraries to make sure that they are in the expected format or have the expected composition. But it's always possible that you'll be just sharing broken or tainted libraries, which is just something that you'll need to apply due diligence to when working with server-side tagging as well. You don't have to trust and hope that the Facebook JavaScript works as it should, because you could even get by without running any Facebook JavaScript at all. As said, you can consolidate those data streams and use the GTag or Google Analytics library instead to send all the information to Facebook. So you're reducing the number of third-party data streams, whether they're directly from the browser to the vendor or from the server to the vendor CDN, and you're mitigating all these risks that way. So the consolidation of data streams is one of the key approaches to server-side tagging, not just from a client-side performance point of view, but also from data security and data privacy. And as for identifiers and cross-site tracking, you get to choose what is passed to the vendors. The vendors can't just run willy-nilly in the browser and choose what pick and mix whatever they want from your cookies or from the document object model. You get to choose exactly which personal data bits you're sending, or which IP addresses you're sending, or which bits of information you're sending. So when moving to server-side tagging, you are taking control of the data flow between the browser and the vendor. You're preventing the browser from directly communicating with the vendor, which in itself already carries huge benefits for your tracking from a data quality perspective, but you're also introducing all these governance and security mechanisms. Every time I talk about server-side tagging, I get the same questions, so I want to ask myself some of the most frequently asked questions. The first question, and this is something we also received prior to this presentation as we sourced for questions from the TechSEO Boost audience. Does this replace client-side tagging? Is this the future of tagging? I would say no. This is a complementary approach to tagging. The server-side tagging is, you should actually just consider it more as a proxy or an API endpoint rather than a way to track things in the browser, for example. If you want to track clicks and form submissions and scroll events and time on page things, you most likely still need some client-side code running in the browser. And the best companion to a server-side tagging endpoint is a Google Tag Manager web container. So those two work really nicely together, and there's going to be additional benefits in the future for using GTM or the global site tag to communicate with the server-side tagging endpoint. But this is not a replacement of client-side tagging. It's an additional parallel data stream to that. Is the server-side tracking is also something that's often asked. It's an umbrella concept for server-side tracking. You can also send those server-to-server hits through the server container prior to them entering the vendor endpoint. So you could use it to collect information from browser server logs and send it forward. But again, it doesn't replace that. You can still communicate directly between servers without having to go through the server-side container. But there are benefits to moving all your marketing and all your analytics work to run through the tag management solution, because you can kind of make sure that they all have required data set, they all have the required metadata and so on. So it's not server-side tracking, but it can incorporate server-side tracking if you so wish. The legality is a hot topic as well. There's nothing inherently illegal about server-side tagging, but when I mentioned opaqueness of data collection, it is a very real problem, and it's possible that legislation will morph to also cover cases of server to server and of server side tagging. Right now, a lot of legislation is based on cookies and client side technologies, but GDPR, for example, is technology agnostic in that all its articles and all its provisions apply to server tracking and tagging as well. But the legality is up to you. If you want to do harmful stuff with server-side tagging, you can. There's no tool in it that prevents you from collecting data that's beyond your permission to collect. Is it future-proofed against ad blockers and tracking protections? This is a very difficult question to answer, and well, actually, it's not. It's a very firm no. But there's nothing in the horizon that would indicate that this is a wasted investment from this point of view. Server-side tagging is, first of all, it's extremely difficult for browser tracking protections to do anything with it because it happens between servers. The browser is no longer a function in it. It's also difficult for ad blockers to impact it because, again, it happens in the server and ad blockers run in the browser. What I do envision happening is that ad blockers and tracking protections get improved heuristic models to identify potential tracking hits in order to prevent them from being sent even to the server. But it would be trivial to work around these with simple client-side hashing or encrypting the data in the client before it's shipped to the server-side endpoint. So in that sense, I do think it's fairly future-proofed. But again, I don't necessarily think it's a good thing that you have all these tools that let you circumvent ad blockers and tracking protections. Just remember to do right by your visitors and do right by the privacy promises that you make in your privacy policy. And don't try to think of ways to circumvent the user's wishes. How do I migrate to server-side tagging? Well, that's a good question. The best way to start is with dual tracking. So when you want to move Facebook to server-side or Google Analytics to server-side, start with creating parallel trackers that collect the same information that you already sent from the client, that they collect the same information through the server as well. And that way you can compare the two to make sure that they end up being as close to each other as possible. And then you can kind of shut down the client-side streams. And Facebook doesn't even want you to shut down the client-side stream. They want you to collect with the Facebook pixel as well and use the server-side convergence API stream to fill in the gaps that the Facebook pixel might miss. And as for all the other vendor endpoints, you just need to wait for those vendors to release documentation how to communicate with those endpoints, at which point someone in the community will most likely create a template, a tag for these vendors that you can then use in the server-side endpoint. Where can I learn more about server-side tagging? I've added some resources here. So I've written a lot about server-side tagging on my blog. The official developer documentation on the Google site is very good. It has all you need to know about the API. And then I've also recorded a couple of videos about server-side tagging. One of them is linked to in this slide. And then I also want to point out that our new company, Simmer, has a course called Server-Side Tagging in Google Tag Manager. You can find it on teamsimmer.com. There's also a newsletter that you can subscribe to. And I recommend subscribing because the enrollment for the course is currently closed. We'll hopefully open it up early May or during May of this year. But we'll announce this in the newsletter and we'll most likely have an offer or a discount for all newsletter subscribers if server-side tagging is what interests you. And that's it for my keynote presentation. Thank you so much for sticking by and for your attention. And I hope that if server-side tagging was a bit blurry to you or a kind of just a small point of interest in your life, I hope that after this presentation, you are inspired to maybe give it a shot. It's completely free to test. Google Cloud has a tier for you that you can test it in a very small controlled environment. So you can kick the tires and see if it's useful for your organization. Thank you so much.
As expected, Simo, that did not disappoint. So thank you so much for this. That was really incredible.
What an awesome presentation indeed. And next up is the Python panel. See you in a few minutes.